Good afternoon, all the students. Now we are going to discuss about our chemistry parts of periodic classifications. Already we are discussed about the different types of our whatever our different type of periodic functions and periodic laws. Dobreiner, Newlands, and as well as the Mendeleev and as well as the modern periodic table. We already completed. Dobreiner said about that atomic weights are arranged in increasing order. The first element and last element, the mean is equal to the middle one. Okay, Newland said that the first element and the eighth element are containing same physical and chemical properties as a function of atomic weights. And Mendeleev also said that the same things. The atomic weights are what the periodic functions of physical and chemical properties of atoms. And the modern periodic table said that actually the atomic number is the physical and chemical properties of atomic atoms and elements. Okay, this is the information we are already considered for our atomic mass and as well as atomic weights and atomic number based periodic laws for a periodic table. Okay, now modern atomic periodic table said that electronic configuration, not the now atomic number, proton number or electron number is only not the decided the periodic properties of atoms. Okay, now which is decided then? Electronic configuration, arrangement of electron in a single atom, single orbit and orbital. That is only affected the physical and chemical properties. Based on that one only, our scientists are divided totally how many? 18 groups and other 7 periods. This 18 groups. Please mute it. Please mute. Alba branch. Alba branch. Please mute. Yeah, here please post is Alba branch. Yeah, here what we are going to do. The periodic law based we are considering. There is a whatever the periodic laws till now we are the electronic configuration is one of the components that is indicate the what actually yes a physical and chemical property. Alval KTS branch. Please mute yourself. Yeah, next year, what we consider the valency already we are considering. What is the valency? What is the valency? In the last class, we have discussed it. What is the valency? Which one is the called valency? Which one is the called valency? The valency is nothing but combined capacity. Combined capacity of a atom or element is only called a valency. What is the combined capacity? The combined capacity is nothing but yes, how many number of electrons are want to last or a gain for get the nearest inert gas configuration. Okay, clear or not? Already I am given that information to you. Yes, whatever the atom is there, that atom is ready to last or gain some electron for get the stability. Yes, when they get the stability, when they become equal to the inert gases, that is called a stable one. For this purpose only, either it may lose the electrons or may gain it the electrons. Got it or not? Yes, already we are discussed. Suppose you take a hydrogen. Hydrogen is wanted to become a helium. When the hydrogen is become helium, it becomes stabilized. Why? Because hydrogen contains one electron. The atomic electronic configuration of hydrogen is 1s1. Okay, now what is the helium configuration? 1s2. It is only the nearest inert gas or not? It is suppose after the helium, what the inert gas is there? Neon. Neon is a 10th. The gain of a 9 electrons is equal. It is a very tough task. It not selected like that. Okay, clear or not? That's why valency of hydrogen is become what? 1. Okay, clear or not? What is the valence of helium? 0. Okay, no requirement. Okay, it's already stable. No need of loss of electron, no need of gain of electrons. Okay, that's why it is called zero group elements also. They're all inert gas names are what? Zero group elements. Helium, neon, krypton, xenon, radon. These all are called zero group elements or 18th group it is. Okay, now yes. And suppose you take the what is the valency means helium we are consider next lithium, next beryllium, next boron, next carbon, next nitrogen, next oxygen, next fluorine. Between helium to neon, what is the elements are there? These are the elements. Then what is the valency of lithium? What is the valency of lithium? What is the valency of lithium? Tell me. 1. Why? Because it lost one electron, it gets the stability. It becomes helium. What is the electronic atomic number of it? 3. Okay, now when it is a become stable, when it is a contain 2 electrons, it becomes stable. How it is become 2 then? Yeah, it lost -1. Got it or not? It means what? Make -1, it will become 2. That is the meaning of it is what? Minus nothing but it lost one electron. Yes, it is one more possibility also there. Get a 7 electrons plus 7. It is also become stabilized. Okay, but 7 getting of electrons, it is a very tough task. Okay, we want to take a 7 electrons from another atom. It is a very tough subject, tough concept. Okay, that is why there is a what the 7 is not taken from the any other atom. Just it lasts 1 electron, automatically it become stabilized. Got it or not? Automatically it become stabilized. Okay, now this is only the thing. And next, afterwards, beryllium. The beryllium is the contain. What is the atomic number? 4. The valency is become 4 minus 2. It is become 2. Okay, clear or not? And what is the boron? Yes, boron is 5. 5 minus this 2. What is the valency? 3. Got it or not? I hope you got it. The valency is 3. What is the valency here? 3. And now the carbon. One second. The carbon have 2 possibilities. Either it's a want to become a yes, what helium. Okay, or it will want to become a neon. Either 4 electron losses or 4 electron gain. Okay, 6 plus 4, 10. 6 minus 4, it is become 2. Okay, now that is why there is the what is the valency of it is 4. Okay, clear or not? Next, come to the nitrogen. What is the nitrogen? Nitrogen want to become helium? No. Why? Because it's required to last 5 electrons. That is a tough concept. Okay, clear or not? That is why it's take the electrons from any other atom, 7 plus 3. That is why the valency is become 3. Oxygen is also added 2 electrons, 8 plus 2, 10. Then it is a what become 10. Okay, valency is become 2. In this way, we are consider the valency. Got it or not? I hope you got it here. The valency is nothing but combining capacity of one atom. Okay, what is the combining capacity? Loss or gain the electrons for a get a stability or become as a nearest inert gas nearest inert gas configuration. Suppose chlorine is there. Chlorine atomic number is how much? 70. After chlorine, what we have? Argon. In case it is gain one electron, automatically it is a become stabilized. That is why what is the valency of sodium? Sorry, chlorine? 1. Okay, clear or not? In this way, either plus 1 or minus 1. When it is losses the electron, it is called plus 1. It is gain the electron, it is called a minus 1. Okay, clear or not? This is only about a valency. Understood all of you students? I hope you got it. It is a valency. The valency in the period, that is what actually increases. Okay, clear or not? In the periods, it is a become increases. From where to where? From 1 to 4 it is increases. Then the 4 to again 7 it is a decreases. 4 to 7 it is a decreases. Once check it all the students. I'll show there is a our whatever our Yeah. One second. There is on the screen. There is a periodic table is there. Okay. In the period means what we are consider. In the period means there is we have to take here. There is a hydrogen and as well as the helium. Yeah, hydrogen and as well as the helium is there. The hydrogen valence is about 1. Helium, the last column, 1 second. In the yellow color, 8th A group, it is looking like a 18th. That is looks like a what? Helium valence is how much? 0 it is. In the first period, that is like. Next, lithium. Okay, in the second period, what is the valency? 2. Third period valency is the what? 4. Sorry, third period valency 3. Fourth period valency 4. Fifth period valency again become 1. Okay, once check it all the students. Then it is started from where? Started from helium. Okay, clear or not? In this way, there is we consider as the third lithium. The next we have the sodium. The valencies have become 1 for that period. Okay, in this way, the periods are okay now 1, 2, yes, 4 periods. The whatever valence is there that increases, and in that yes, the groups it will be remain same. Why? Because in a group, suppose you take a lithium, sodium, okay, potassium, they contain valency 1 only not. Suppose you take a lithium is a 1, and already these are there. Sodium, how it is a become 1? Tell me. Sodium atomic number is 11. It want to become a 10. What it is? 1 or not? 1 electron is a losses. Automatically, it is become as a yes valency 1. And 1 second potassium also. Okay, now what is that? 19. Atomic number is what? 19. The 19 is a become 18. It is become stabilized. What is the 18? Argon. Okay, that's why it lost 1 electron. It become what? Stabilized. That is why the valence is become 1 only. Got it or not? In this way, we are consider about our valence is how changes in a periods and as well as the groups. It's a very important question. In the periods 1 to 4, it is increases. Then after again decreases. Okay, 1 to 4 periods it is increases. Then after it is decreases. Got it or not? And the next what we are consider, there is a first 1 to 4th element here in the not a period. First period, second period, third period, fourth period. Okay, now in the first period we contain only the how many number of atoms? There is only 2. Second period is a contain 8. In that 8, first 4 elements are increases. It's a valency. In the second period, what the things are there? Lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine. Second period elements are what you know. These are the second period valency. Second period elements. Okay, clear or not all the students? The second period is a what? The second period is a taken as lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine. 1 second, there is a first 4 elements. Up to first 4 elements, the valency increases or not? The first one is our 1. Second one is our 2. Third one is our 3. Fourth one is our 4. 1, 2, 3, 4 increases. Then what becomes? Decreases or not? 1 second. Yes, nitrogen 3, oxygen 2, fluorine 1. Okay, now first 4 elements are increases. It's a valency. Say after the 4th element, there is a decreasing in the valency occurs. In a where? In a periods. But in a groups, it will become same. Understood or not all the students? Once again, check all the on the screen, it will be available. Okay, now. Once check it all the students. On the screen, it will be yes, first the lithium. What is the valency? 1. Beryllium 2. Boron. What is the valency? Boron 3. Carbon 4. Nitrogen is become what? Again 3. Okay, now oxygen is become what? 2. As fluorine is become 1. Okay, now and neon is become 0. Like that. First 4 is increases. The next 4 again decreases. Okay, now third group 1 second. Sodium 1. Magnesium 2. Okay, na? Aluminium 3, silicon 4, phosphorus 3. Okay, clear. Sulfur 2. Okay, na? Chlorine 1, argon 0. Like that, in the periods, the first 4 elements are increases its valency, then after it will be decreases. Okay, now the groups once check it. Now first group elements are what? Lithium, sodium, potassium, rubidium, cesium, francium. These are the first group elements. The first group element, whatever the valence you have to take, it is one only. That is why only it is called first group. Second A group. Okay, it is a magnesium, beryllium, magnesium, calcium, francium, barium, radium. These are contain how much valency? 2 only. Okay, now there is no change in the valency. Like that, in the groups, there is no change in the valency, but in the period, first 4 elements are increases its valency. Next, whatever the next things are there, it will be not increases, it is a decreases. Next elements, first 4 is only increases. Next 4 not increases. Okay, yes. Next one is atomic size. Next property is about atomic size. Next thing is atomic size. Which one is called atomic size? Okay, now the atomic size is nothing but there is we are consider what? This is called atomic size. Yes, the distance between nucleus to the outermost orbital. Nucleus to the outermost orbital is called as what? Atomic size. Okay, clear or not, all the students? Okay, got it or not? Yes, there is a whatever the atomic size is there, we consider from where. Yes, it will be what actually there is. We consider the distance between. This is actually atomic radius. This is called what? Atomic radius. Yes, there it will be distance between the nucleus to the outermost orbital is only called what? Atomic radius. The atomic radius is only increases atomic. It is depending on the atomic sizes. Okay, now yes, and how the atomic sizes are changes. Okay, now clear or not? How the atomic sizes are changes in whatever our periods and as well as the groups. Okay. Yeah, we are taken always left to right in the periods. Actually, the whatever the changes of the variation we are considered from where, from left to right we are considered. Yes, and as well as there is a groups are be taken from top to bottom. The whatever the changes are we are considered left to right, and as well as the yes top to bottom we are considered. Yes, that is only we are taken here. Yeah, here there is in a groups, it will be what? Increases. The atomic size is increases. Why there is a groups in atomic size is increases? You know very well. There is a what we are considered lithium, sodium. Okay, clear or not? And as well as the next potassium. Okay, now like that when we are consider the atomic number is increases or not? What is the atomic number is increases? Lithium is a yes 3 and it is 11. It is a 19. What is electronic configuration? 1 is 2 and as well as the 2 is 1. What is electronic configuration? 1 is 2, 2 is 2, 2p6, 3 is 1. Okay, now what is electronic configuration? Then it is taken as 1s2, 2s2, 2p6, 3s2, okay, 3p6, 4s1. Okay, now yes. Now there is how many orbits are available? 4 orbits are available in a where? In a potassium. In there is what we are considered. Then the sodium. There is all how many are there here totally? Yes, there is we are consider 3, and there is we consider what 1, 2. Yes, it will become what actually? It will be 2 orbits only. Here it is a 3 orbits. It is here 4 orbits. Okay, how we draw there is in case atomic yes sign here. This is for what? Sodium only. We want to write for potassium, one more orbit may add it. Okay, na? Like that, atomic number is increases in a groups. Okay, na? That is why then it will become what actually? It will become increases. The atomic size is increases. Okay, when you compare atomic radius, elements are decreases across the period from left to right. The reason is electron enter into the same main shell or even inner shell in case D black and F black. Therefore, there should be no change in the distance between a nucleus and outer shell. But nuclear charge is increases. Because of that increase in the atomic number, the elements in a periods, there is a atomic size is decreases. You get somewhat doubt here. Okay, clear or not all the students? When we are taken in the groups, there is atomic number is increases. Atomic number is increases. What we call size is increases. But the same thing, what we call atomic number is increases in where in a period also, left to right. What is the left to right? Suppose you take a second period. What is atomic atoms are present in a second period? Lithium, beryllium, boron, carbon. Okay, clear or not? And as well as there is we consider nitrogen, oxygen, fluorine, neon. What is the atomic number? 3 and as well as the 10. According to whatever we discussed for the groups, here also atomic size is increases or not? Increases or not? But it is not increases. In our textbook they given decreases. It is wrong? No. It is decreases only. Why? In the groups there is a number of main shells are increases. Okay, clear or not? Increases or not? The lithium contain only 2 main shells. 1s, 2s. Okay, now when you compare sodium 1s2, 2s2, 2p6, 3s, 3 orbits are there. In a potassium, 4 orbits are there. One second, what happened in the period? There is a lithium contain how many orbits? What is the electronic configuration? 1s2, 2s1. That's it or not? It is the same inner shell or not? When you consider beryllium 1s2, 2s2. There is atomic size is increases. No. Suppose we have to draw any atomic size for a lithium, it will be looks in this manner. But electrons here 2, here like this it is. And for a beryllium, okay, the same we have to draw. Okay, no more other shell we have to draw here. It is a required? No. Got it or not? Any requirement is there? No requirement. Okay, now then the same shell only the electrons are arranged or not? Here 2, here 2, 1s2, 2s2. Got it or not? There is a no size is increases. Okay, clear or not? Suppose you take a fluorine also. Fluorine contains 9 electrons. Okay, now what is that electronic configuration? 1s2, 2s, 2, 2p5. What is the orbits? How many orbits are there? The same as like that, 2 only. More orbits are there? No, 2 orbits are only there. Electrons in a periods, when you come from left to right, electrons are accommodated where? In a same shell. In a same shell only. Okay, clear or not? No requirement of any other shell. Okay, simply when you consider 8th class students are there, 9th class students are there, 10th class students are there. Yes. In when you are in a prayer, you have to, okay, no, in the prayer, suppose in assembly we are standing on that 8th, 9th and 10th students. Okay, no? Yes. When you are go for a particularly column based, 8th class group students are increases, Okay, na? The column is whatever the column is appeared for you. It is in a what actually? They are in a what? The size is increases. That is the called a period actually. But you are in a 8th class only. There is a only line increases. That's it. Okay, clear or not? But when you are consider it is a 9th class. Okay, na? 8th class and 10th class. You are added with the one another. What happened? The line is increases or not? In a 8th class, it is never increases the line. Just the number is increases. That's it. Okay, now, but when we are taken a 9th class, there is a what? The heights are also may increases or not? Like that, the groups, the whatever only 8th class students are added with the one more 8th class, one more 8th class. Just in the 8th class only we are added. Na? There is no increase in the class sizes. Okay, now, but when we require 9th class, one more orbit is also required. That is a group. Okay, now period is nothing but in that row only we are going. In that particular row only we are going. There is no need of any extra orbit. But the same become na. In case the second orbit is there, here also second orbit, here also second orbit, here also second orbit. The vacancies are only there here. Okay, clear or not? What happened here? Only vacancies are there here. There is how many vacancies are there? Totally 7 vacancies are there in this orbit. In this one, how many vacancies are there? There is a 6 vacancies. Here in the fluorine, only 1 vacancy for electron. Vacancy only there, but why decreases? Why decreases? The decreasing is why? Because you know the number of electrons are increases. Clear or not? Yes. Compare with the lithium, there is a fluorine is a contain. How many electrons are more? Okay, na? Yes. There is a 6 electrons or more. Okay, clear or not? What is the lithium atomic number? 3. What is the atomic number of fluorine? 9. Difference is how many? 6. 6 electrons are increases. Because of increasing of a charge number, the atom become what? Yes, decreases its size. Okay, why? It's a more attraction is available between the protons and as well as these electrons. That's why the atom looks like somewhat decreasing in a size. This is a very, very important point, you students. Yes, in the group, there it will be increases. The size of atom is increases. In the period, it is a decreases. The reason is important. The reason is what? When in the period, atomic number is increases, but there is a no what extra shells are not required. No extra main shells are not required. Okay, now main orbits are not required. No main orbits are not required. Extra main orbits are not required for us. Only what we require then? Yes, number of electrons are increases, and because of that, charges are increases. Because of the charge increases, the attraction of the neutron and proton, electron and proton, the atomic size is decreases. Got it or not? The atomic size is decreases. This is only the thing we are considered for atomic sizes. Okay, I hope you understood it. Yes. And what is atomic size? What is atomic size? The distance between a nucleus to the outermost orbital, last orbital available in that atom. Okay, that is only called what? Atomic radius actually. The based on atomic radius only we are consider atomic size also. Radius is doubled, it is become diameter. Based on the diameter only, that whatever our sphere nature is increases. Okay, now the diameter is increases, sphere is increases or not? In this way only we are consider about that our yes atoms and atomic sizes and all these things. Got it or not? This is about our yes atomic radius. And one more thing is also there, the metallic character and as well as the non-metallic character. Okay, clear or not all the students? Which are contained in metallic nature, which are contained in non-metallic nature. In a periods, the property is the what actually? In a period, the property is a decreases. In the groups, it is increases. And the non-metallic character nature, in the period, it will be increases, non-metallic nature. And in a group, it is a decreases. What is the metallic nature and what is the non-metallic nature? All the 8th class students, you have in your regular syllabus also about the metals and as well as the non-metals. Okay, clear or not all the students? You have the metals and as well as the Yes, non-metals. The metallic and non-metallic things are totally depending on the two things: ionization energy and as well as electronegativity. Loss of electron is a more. It is a content. Okay, now yes, more metallic nature. Which are gives the ready to give the electrons. It is a content more metallic nature. Which are not ready to give the electron easily. That is the content non-metallic nature. It is accept the electrons. It will be taken electron from others. Okay, now that is the content non-metallic nature. Okay, now which are gives the electrons, it is the called what? Metallic nature. In the metal, what it is? Lithium metal, beryllium metal, boron metal only. Okay, now sodium, magnesium, aluminum, these are metals only. They give the electrons, easily give the electrons. Okay, clear or not all the students? And as well as there is a, when you check it here, yes, our whatever our whatever our oxygen, fluorine, these nitrogen, they are become what? Non-metallic in nature. Why? Because they accept the electron. Chlorine, okay, now yes, sulfur, these are all what? Non-metals only. Okay, clear or not? Zinc is a metal, copper is a metal. Why? They give the electron, ready to give the electrons to the other atoms. Okay, clear or not? Ferrous is a metal. Okay, why? Because it's a gives ready to give the two electrons to the others. Okay, like that, there is a what? Electrons are a giving nature is a more. Okay, now yes, when we are considering a periods, it will decreases. Okay, clear? Up to 4 it is increases, then after it is decreases or not? In this manner, there is in the periods left to right, it is a decreases metallic nature. Non-metallic nature is increases. When the metallic nature is increases, decreases, non-metallic automatically decreases or not? Yeah, that is a very, very important. And in the first page, whatever the given, yes, that is not a single page. This is only today's class, all the students, and the remaining we are considered later. Yes, whatever S black elements are there and electronic configurations, what is there in a periods, and as well as the properties of S black elements, P black elements, F black elements, and all these things we are going to discuss tomorrow. Okay. Yes, thank you one and all. Yes, please read the. Okay, now whatever the 10th class textbook it is there with you. If your brothers and sisters are there in that one, these all the things are there. Okay, about a Mendeleev periodic table, about the whatever Dobrynin triad, Newland's active, and as well as this valency what, and what is the atomic radius, and as well as the, what is the metallic nature, what is the non-metallic nature, everything will be there. Once check it through that clearly you required it. Okay, now already I am given that all the things. Just once go through the textbook, it will become easy for you. Okay, thank you.